Hello and welcome to the first day of internship week. We are glad to see you here. My name is Jan Potsman. I oversee internships for the Career Center. I'm an assistant director and I've been working with internships for over 20 years. So I'm pleased today to introduce you to Michael Hagenmiller. He was an intern with Southern California Edison for 3 years, and upon his graduation from UCLA in March of 2021, with his bachelor's degree in electrical engineering, he was converted to a full-time distribution engineer. He primarily supports the Valencia district and is heavily involved with the development and execution of SCE's wildfire mitigation plan across Southern California. He is also responsible for recruiting engineers from CSUN, Cal Poly San Luis Obispo, and UCLA. Welcome, Michael.
Thank you, Jan, for that introduction. Good afternoon, everybody. As Jan said, my name is Michael Hagenmiller. I'm an engineer with SoCal Edison, and let's dive into our presentation today. There we go. A little bit of background about myself. I guess first and foremost, let's address questions. If you guys have questions as they come up, you can throw them in the chat, and after each slide, I'll try to address them as they roll in. If you guys want to ask your questions verbally, go ahead and raise your hand and go ahead. And we also have some time at the end reserved for Q&A. All right, so a little bit about myself.
Actually, Michael, before you get started, all the questions have to go through the chat because we are recording today and we'll be posting. That's why we ask that your cameras remain off and that you are on silent. So questions have to go through the chat, and we have somebody that will read them to Michael when they come they come in.
Got it. Thank you for that clarification. All right, so a little bit about myself. I grew up in the Santa Clarita Valley. As in high school, I worked at Six Flags, and then I went to UCLA for my undergraduate degree. I was fortunate enough to get a summer internship with SoCal Edison after my freshman year, and then I just stayed on with Southern California Edison until I graduated in March of 2021. And it's been almost a year, wow, that I've been a distribution engineer full time. So a little background, what we do and how we do it. Southern California Edison is headquartered in Rosemead, California. They're a subsidiary of Edison International. And we like to start all of our meetings with a safety moment. So as you can see, this is Walter the Squirrel. You might have seen him in some of our ads on the TV. Keep tools 10 feet from power lines. That's hugely important. A lot of our electricity is distributed at high voltages, and that's incredibly dangerous, especially with metal tools or anything metal that conducts electricity. So definitely best practice to stay away from power lines. If you see a power line on the ground, definitely stay away from it. We have a lot of infrastructure to ensure that if there is a wire down situation, that power line is de-energized, but that is not always guaranteed. Sometimes there are interesting cases where they remain energized and on the ground. So always steer clear of those power lines and call 911. A little bit about the company. We've been around for 135 years, and last year we had 2020, we had an operating revenue of $13.5 billion. And we employ a workforce of over 13,000 people, which is also supplemented by over 3,000 contractors to help us do what we do every single day. So high level, this is our service territory. This is where we provide power throughout Southern and Central California. A couple of quick stats. Our service territory is over 50,000 square miles. We serve 15 counties, and we have over 5 million customer accounts, which equates to about 15 million people. And then our peak loading that we've seen on our system is 24,852 megawatts. It's quite a bit of power. Next is just to show you a little bit more detail about how we break up this area. We break it up into districts, we break it up into regions, and then a sublevel is districts. So I'm primarily responsible for the Valencia district here. So all the substation, all the circuits, all the power lines in that area is my responsibility as the distribution engineer. Next, we have our high-level overview of how the power system works. So this is a pretty traditional model for the grid in general. Historically, you have a generating station, and this is producing all your power. This right here is example of our Big Creek facility. This is up in Northern California, and this facility is over 100 years old. It's pretty incredible that it's still operating today. So they take this power, they generate it, and then they go through a step-up transformer to our transmission level voltages. That's these 500 kV and 220,000 kilovolt levels. Then they're on all these big towers that you'll see running along freeways, going over mountains. There's a lot of big infrastructure that holds up these wires. These traverse the state all over, and then they come down to our transmission level substations, and they'll go through a step down transformer, step down the voltage from 500 or 220 kV down to 115 or 66 kV. And then these are typically supported on poles. They also can be supported on towers. This allows us to get a little more granular and get into more neighborhoods. Then you'll have your local distribution substations. As you can see here, an overview. You'll probably see these around town, a little more familiar with them, where again, there's a step down transformer that takes the voltage from 115 or 66 kV, and it'll step it down to 33 kV, 16 kV, 12 kV, or 4 kV, depending on the area. Lastly, these are the circuits that you'll see all over the place, the most normal poles and wires going to your homes, your businesses, everything around you is how most people get their power. Here we have an overview of all the facilities and infrastructure that we have. We have over 800 distribution substations, over 4,500 distribution circuits, and here's the big one, over 100,000 miles of circuitry traversing the Southland, and all of that is supported by almost 1.5 million poles. So as you can imagine, there's a lot of infrastructure out there, and we have very robust systems and data analysis that tells us, when our infrastructure is aging, when new upgrades might need to happen, when they need to be determined, and when replacements need to occur. So we have very robust systems in place for all of that. So we're gonna take a look at some examples of our distribution equipment. So as you can see here, we have a pretty standard power pole. This one has streetlights on it. Different entities can decide to operate their own streetlights, or they can pay us monthly to operate their streetlights. This pole is a little bit more interesting. It has some fuses right here on this dip, and the dip comes down the pole, and so the overhead wires actually convert into underground wires right here, and then you'll have an underground cable and structure system beneath it. So this portion's a little bit interactive, and I recognize you can't speak at the moment. So if you can put it in the chat, does anyone know what this green box is? Timothy, a generator. Oh, go ahead, sorry.
Oh, no, it's fine. You can read it as well. Timothy says a generator.
Yeah, a generator. Not quite. That's a good guess. Any other guesses out there?
A breaker.
It's not a breaker either. Wow. Okay, you actually know quite a bit of infrastructure. That's good. Christian, power distribution box.
Okay, I'll go ahead and let you read them. My apologies.
Oh, thank you. Yeah, sorry. Yeah, I can read them. Power distribution box, pretty much. Yeah. So this is a transformer. So this is a pad-mounted transformer. The circuit is coming in underground at 16,000 volts, 16 kV. And you can see a couple things on here. In the top left, we have the structure number for this particular transformer. And in the bottom left, you can see this number. This is the rating for the transformer. So it's a 500 kVA kilovolt amp transformer. That's how much power it's rated to convert. So here we have an example of a pad-mounted switch here, also in a green box. They'll also have a structure number on the front. And then you can see here underground is a vault. And this vault has vent pipes, which means that it also has a switch or even automation in it. Automation is hugely important as we continue to move forward. We like to have a smart grid, is what people like to refer to it as. And this is a grid that can heal itself and continue to keep our customers energized to the best of its abilities. So next we have here is an overhead transformer bank. I'm sure you guys have seen these around on poles everywhere. You can see here we have the cross arm, and then we have the high side transformer fuses. And then each one of these is a 25 kVA transformer, and they're all banked together. So this will actually be a 75 kVA transformer bank. Yeah, so that's huge. And it's really interesting to see how big these things actually are. Standing next to them, when they're up on a pole 40 feet high, you don't really have a great idea of how big things can be. And then you stand next to it and they're taller than you. And it's like, wow, okay, interesting. So a couple more of our devices, some things you might see around are these poles with these white boxes on the side. And that's some sort of automation. Here we have a pole switch that's being automated. So this is what we'd call a remote control switch. These are deployed all over, and they're often used as circuit ties, where two circuits meet, they'll meet up against each other. That remote control switch will normally be open. But if there is an event like a wire down or some customers lose power, we're able to close in that switch and feed those customers from a different circuit. This is an underground remote control switch. They're a lot less interesting to look at. They're also housed in those green boxes, or can be in underground vaults. Another very important piece of infrastructure that we have is remote automatic reclosers and remote sectionalizing reclosers. So remote automatic reclosers have relay settings, which means if these are essentially a protection device. So if they see a wire down beyond this device will operate. It's basically a circuit breaker. It'll open up, and the customers upstream of that will remain energized. So only the customers downstream of this device will be affected by that outage. So these are incredibly important for our reliability. And I actually took this picture. This particular RAR is right off the 5 freeway going up the Newhall Pass. Another piece of equipment that's really insightful to helping us restore power if we are to experience a power outage anywhere is a remote fault indicator. As you can see, they're just these little boxes that go on the lines, and they are parasitic in most instances, which means they take power from the line itself. And so if there is a wire down, there's a power outage, this little red light will turn on. And that lets us know that there is a wire down. These customers are not seeing power. So we have troublemen in every district that are on call, on duty 24/7. There's always someone. So if there is, a car hit pole, or someone loses power in the middle of the night, there's always someone to respond to that event. These devices help those folks determine where exactly the incident occurred, and allows us to pinpoint it, and allows us to pick up as many customers around in the area that don't necessarily need to be affected by it if we have appropriate measures in place. Here's another large piece of equipment. This is a field voltage regulator. These are not very common in urban settings, but in our rural areas, as you can imagine, we served a lot of the eastern part of the state that butts up against Nevada and Arizona border. And so some of the circuits are really, really long, 20 miles long. And so the voltage drops, because there's impedance in the lines. So sometimes you need a voltage regulator to help level out the voltage. If you have high voltage or low voltage, it'll standardize it and make it within the rules that we have to distribute the voltages in. Lastly, here's our field capacitor. This is also a large piece of equipment. When you're looking up on a pole, you're like, oh, there's little boxes up there. This is also very large. You can see each one of these little boxes is a capacitor, and then they're all banked together. And this is actually a switched capacitor, so it doesn't always need to be closed in. Let's say, during the mornings, there's not too many people, running the air conditioning, so there's light load. The capacitor bank will remain open. And then in the afternoons, let's say it's a hot day, everyone turns their air conditioners on, there's a lot more load. So there's a greater need for more VAR support. So the capacitor will close in, and it'll support the VARs on the circuit, and to ensure that all the power getting delivered is quality power. Okay, I don't see any questions, so I'll continue going. So here's an example, high level of a distribution system power flow, how it was, how we traditionally designed circuits. So we start here at our distribution substation, and the power goes down the lines, and it comes to the transformers that can serve your business, your office, your house. And so here we can see a normally open switch. This is an adjacent substation feeding a different circuit. So let's see what happens if we were to introduce. So, oh yeah, this is a cute graphic. Send out all the electrons. Everyone gets the power. Turn the light bulbs on. There you go. And then let's see what happens if something unexpected happens. Let's say a car comes in, it hits a pole, the wire comes down. Obviously, this creates a very dangerous scenario. So what happens immediately, you see the circuit breaker fly in. The circuit breaker housed at the substation is going to sense that there's been a wire down, and it immediately opens, de-energizing this entire circuit. So the power is no longer flowing. You see these light bulbs turned off up here. They're not on anymore, so power is not flowing. This immediately hits an alarm, and that goes to our system operators. I assure you their setups are far more advanced than this picture might show. They have probably 10 monitors each. They have really crazy setups because they're monitoring the entire grid at any given point in time. So they immediately get an alarm, and it says, hey, this circuit just experienced an event and the circuit breaker opened up. You might want to look into that. How can you fix the power? So what they can do is they can close in the switch on the back half, energizing the circuit from a different substation. That way, all these customers can get power back as soon as possible. This can be done a couple ways. Some of these switches, as we discussed, are remote controlled switches, so the operators can do it themselves. They hit a button, the switch closes in, restores the power. Some of our switches are not remote controlled. They're just pull switches. They have to be manually operated. And that's when we send those troublemen out there to go close the switch in, restoring power to all of our customers. All right, so let's take a look at another example. You guys probably have seen solar panels on people's houses, in businesses, in parking lots. So let's take a look at how our grid is evolving. So this is an example. It's going to be a distribution system, the power flow with generation. So this red line here is the traditional power flow we just looked at. So we'll get rid of that, and we'll install some generation. Let's say these businesses, they want to install some solar, and we also have a generating facility that wants to connect in the area. So they will start, let's say there's light loading conditions and the sun's out. So they're generating at full peak. They'll start actually sending power back to the grid. So what used to be power flow from the distribution substation to all the customers, now that flow is reversed. So each generator is sending back its power, sending it to the grid. And you can see up here, this customer is actually going to take their power almost directly to them. We're just supplying the wires to be the conduit between them. So here we go. Yeah, we in certain circuits and under certain conditions, we can absolutely see reverse power flow all the way back up through the distribution substation and feed back up to our subtransmission lines. So that's something that when these circuits and the grid as a whole, when it was originally designed, over 100 years ago, a lot of people did not consider, having distributed energy resources all over the grid. So they built these a lot of this infrastructure with the power flow in mind, going from one way to the other. So that's presenting a lot of unique challenges that we face today. Here's our overview slide. Normally it goes one direction power flow, and now we're seeing, a lot of customers and generators actually producing power, and we can see their power going back up through the grid. This is important because some of our devices are only one directional. And so a lot of those devices need to be phased out and upgraded so that they have bidirectional power flow reads, and they're able to protect the circuits in both directions. Additionally, this can distributed energy resources can also contribute to high voltage situations. If you have good voltage from the substation, and then you connect another generator to the line, now you're getting a lot of power, and that could be boosting the voltage to what is outside of our standards. So we have policies in place to help limit that, but that's something that I do as a distribution engineer. If someone's experiencing high or low voltage, I'll take a look at what could possibly be going on and try to troubleshoot that particular instance and try to resolve it so that all the customers can get good voltage. Next, it wouldn't be California if we didn't talk about wildfires. So this is a recap of some of our wildfire mitigation activities. So on this slide is our 2020 wildfire mitigation activities, and I'll point out the big ones. Here we have our covered conductor. In 2020, we sought to install 700 miles of covered conductor, and we actually installed 960 miles. This was a huge effort for all parties involved, especially our customers. Seeing outages to do work to harden the grid is really tough whenever your power goes out, and we're very cognizant of that. One thing that's also really changed the utility industry in the last 5 years is the implementation of the public safety power shutoffs. So that's when the utility, it's like super windy outside, there's like a red flag warning, and the utility will decide to turn the power off because it is a risk to public safety. There's a very large risk of starting potentially what could be a catastrophic wildfire. So recently, we've seen a lot of investment from all of our public-owned utilities in Southland, PG&E, SDG&E, as well as SCE in weather stations. So in 2020, we installed 590 new weather stations, and this allows us to have a more granular view of what's happening across the grid. So if it's windy at your house, it might not be windy at my house. So that allows us to see in a lot more detail where a public safety power shutoff might be necessary. In conjunction with all these weather stations, we also installed 49 sectionalizing devices for the specific use of PSPS to limit the outages to as few customers as possible. Another thing I'll highlight on here is the very bottom is our community resource centers and our community crew vehicles. These centers and these vehicles respond to PSPS events and support those communities when they experience a PSPS de-energization. We have SCE employees, they volunteer for these positions, and they'll go out to the community and they bring generators, they bring food and snacks, cases of water, they bring portable generators, so if people need to charge their phones or laptops, whatever they need, they can show up to these stations and they can get those resources available to them. Here's our 2021 wildfire mitigation activities. These were just published. One huge jump we saw is we installed 1,500 additional miles of covered conductor. This is the most cost-effective solution we have in our high fire risk areas, is covering the line. You can see an example here. If a branch or a tree comes into contact with the line, there's actually this little bit of plastic and rubber insulation around the conductor so that it does not arc or spark if something were to come in contact with the lines. Another thing that we've been doing is installing composite poles. You can imagine if a wildfire goes through and it has wood poles, the wood poles will likely burn, and then you have to replace all that infrastructure. Our composite poles have a much, much higher burning point and melting point. So there is much less infrastructure to replace if a wildfire were to go through. And lastly, what have been distributed in mass across all those circuits that traverse high fire risk areas are the installation of these fast acting fuses. They're called current limiting fuses. And you can see a cross section of one here. You can see these shiny metal components. These are the current limiting components. And then there's the more traditional fuse components in the middle that work for lower amperage faults. So these are really cool when they do see a fault and they see too much current. These metal bits actually melt, and there's sand in here, and so then they melt the sand and it turns to glass. And glass is an insulator, so the electricity doesn't flow through the fuses anymore. So what does a distribution engineer do? This is kind of a misleading picture. We do not fly helicopters. That'd be super cool if we did, but I don't have my pilot's license. But Edison has, donated a few helicopters to CAL FIRE, and these helicopters are for the intended use of supporting fire efforts in Ventura, Los Angeles, and Orange counties. So those are really cool, the latest and greatest. They can hold something like 2,000 gallons of water per drop. So that's huge in fighting wildfires. We also don't fly drones. However, our ops department does. And this is hugely important because we have been taking pictures and analyzing every single pole in our high fire risk areas every year for the last 5 years. So they'll go out there with drones, with helicopters, as well as on the ground, and they'll look at every asset that we have in high fire risk areas and take pictures of it. And then we actually have been developing our own artificial intelligence to go through all these pictures and identify hazards in the photos. So if you go out to a pole, you're standing at the ground level and you're looking up. And that's great if you can see something that might look amiss that needs to be investigated further. However, when we have our drones go out and they perform aerial inspections, top down, they can actually see problems before they turn into problems. So if there's a little bit of arcing between the lines and the top of the pole, and it's actually burning the pole a little bit, it's not enough to start a fire, but there's enough to leave traces of a little bit of burned wood right at the top. And so with our aerial inspections, we're able to identify those things, and then we're able to go and replace those poles, as soon as possible. Sometimes as quick as the same day, depending on how big of an issue each photo presents. Another thing that people may not consider, this is also a voltage regulator. As we saw, the Edison service territory goes all the way up to Arrowhead, Big Bear, Mammoth. So something a lot of people from Southern California might not consider is, our infrastructure needs to be able to handle ice and snow loading. And so when you get out there and you get a wire down from the snow, you're like, wait, we have snow? We have to plan for that? Yes, absolutely, we have to plan for that. So we have standards specifically designed for our communities that experience more traditional winter weather. Right here, this is a picture of one of our substations up in the San Joaquin Valley. As distribution engineers, we do sponsor a number of projects inside the substation, whether we need a new circuit or if we need a new substation entirely. If there's a lot of load growth in a particular area, we may need to build a new substation to feed all of those customers and those growing communities. In the bottom right here, you'll see a picture of a Tehachapi wind farm. As you can imagine, up in the high desert, there's a lot of wind, and so that's a great place for renewable energy. But there also isn't a lot of load up in the high desert. So we need a lot of these transmission lines to help bring that power down here to the greater Los Angeles area. So the Tehachapi Renewable Project, we built a new set of transmission lines, which you can see here. This is them terminating at our Mira Loma substation. So we're taking all that power, bringing it down here to the LA area. And in the foreground, you can actually see a 100 megawatt Tesla battery installation. So this is inside our substation, utility owned battery storage solution. And so we'll charge these batteries like in the night when the peak loading is way down, the load on the circuit is down, we'll charge the batteries up. And then during the day, if it's really hot and everyone's operating their air conditioners, then we can discharge those batteries to help offset the peak of the circuit. Here in the middle, you can see a commercial solar installation. This is on top of one of our local schools. As distribution engineers, we have to look at all of these and commission the projects to make sure that all of the gear that they're implementing, their switch gear, their inverter settings, their relay protection settings, we have to review all of that to make sure it's compliant with our standards. We can't just have people, hooking their stuff up to the grid. That doesn't make for a very consistent application. And here we have an RAR. This is the same one that we saw earlier. We propose new areas for RARs where we can improve reliability in certain areas. And we also propose the initial settings as distribution engineers. So whatever the settings are for like the circuit, you might see 100 amps on the circuit as normal loading. So we do not want the RAR to trip on normal loading. We only want it to trip if there's like a wire down. When there's a wire down, that's like a phase to ground fault, and you'll see the amps on that circuit shoot way up from what is normally 100 amps to over 1,000 amps in this particular instance. And then when this device sees that jump in the amps, it immediately opens and turns the power off to that fault. Some other things we do our short circuit duty calculations. So what that is we calculate the fault duty at any given location. When new businesses interconnect to the grid, we have to perform that calculation for them so that their equipment can be rated appropriately. Every county requires that. We do our primary wire down reviews. So if an energized wire comes down, a distribution engineer has to look at it to ensure that nothing was damaged in the process. Obviously, the wire that came down was damaged, and our troubleman and our crews will go out and fix it. But we need to make sure that no upstream infrastructure was damaged. So we'll model the circuit, and we'll take a look to see if all the conductor and the structures were rated for the amount of current that it saw for that period of time. Distribution engineers also perform short circuit duty inquiries, or excuse me, circuit history inquiries. So if you are an SCE customer and you want to know how many power outages you've had in the last year or 3 to 5 years, you can go to sce.com and you can request a circuit history inquiry. And me or one of my colleagues will perform that for you. We'll write up a report for when you saw power outages for whatever time period specified. We also support our PSPS efforts, the public safety power shutoffs. That's entailed a lot these last couple years. We're supporting hundreds of new projects to help reduce the amount of PSPS that's necessary. We do not take turning the power off lightly. That is our last line of defense for public safety. And you can imagine that people pay an Edison bill, right, to receive power. So we are in the business of transmitting and distribute power. And when we turn the power off, we do not transmit or distribute it. And that's primarily how we recover our revenue, is through rates. So we do not take that lightly. It's absolutely the last line of defense. Additionally, we do a lot of temporary generation reviews. We have a lot of these covered conductor projects that we mentioned in high fire risk areas. And so in the previous example, you saw a circuit that had a circuit tie. It was able, when the wire down happened, you were able to close in that switch on the back half and energize all those customers. If we do not have a circuit tie at the end of a circuit and we're installing like all this covered conductor, we actually will deploy temporary generators. And so we have to look at, how many generators do we need? Where do we need to put them? And do we have the protection necessary so that if there's a wire down while there's temporary generators, we'll still be able to interrupt the circuit. That way we're not creating a public safety issue. As I mentioned earlier, we perform voltage studies that might drive the need for voltage regulators or an additional capacitor bank. We do a lot of circuit modeling. So that's very interesting tools to work with there. And yeah, that's pretty much a lot of what we do. I know that was a lot. So please, if anyone has any questions about anything in particular, please, throw them in the chat. Timothy, thank you for the question. What happens to the power that is generated by solar and returned upstream? So that's a great question. It will, let me see, where can we go here? Let me go back one more. Yeah, it'll get redistributed throughout the grid. So there is not enough power to, for it to just go nowhere. So people are always using power. And so what it'll do is it'll go to different load centers. So if this circuit is producing a lot of generation that's back feeding up through the substation, there are lots of circuits out of every substation. So that's probably pretty unique to this circuit in particular, and it'll go up to the busing at the substation, and it'll actually flow back down through an adjacent circuit. Let's say for some reason there's just so much generation out of the substation that it is flowing up back through the subtransmission level. It'll kind of repeat the same process up until a substation or a networked area to where all that load can be dispersed, where there's enough load demand to absorb that power. Christian, I see your question. Are we required to take the PE exam? No, not required. I have my EIT and I'm actively studying for the PE exam right now, but it is not required. I know LAGWP requires all of their engineers to take the PE exam, but Edison does not require you to do it as a part of your employment, but they will pay for it if you pass. So they'll reimburse you. So it's just another tool you can add to your tool belt, but not required. Those are great questions. Thank you, guys. Yeah, of course. So this is, now I'll give you a little more perspective on all the different groups that we interact with. I like to say that our distribution engineering organization is kind of like the jack of all trades engineer, because we just interface with so many different groups, and we also interact directly with the public. So if you're trying to connect to the grid, you're a large generator or you're going to be a large load, you got to come talk to us. And so we're kind of that gateway. We have our hands in a lot of pies, if you will. We're very heavily involved across all of our different departments. So here we are, distribution engineering. We work closely with the switching center, the guys, controlling the grid. If they need to change something or they identify concerns, they'll raise them to us and we'll see what we can do to address them. Next, we have our planning departments, local planning, technical planning, new development planning. So our interaction with them is largely, we will develop the scope for a project. We'll put a package together outlining what we want done. And then the planning departments will take that and they will actually literally design, this pole needs to be placed here and it needs to be a 40-foot pole per our standards. So they'll translate what is basically our high level scope into tangible CAD drawings. Next, we have our project management groups. We have our WPM and DPM. WPM stands for Wildfire Project Management, and DPM stands for Distribution Project Management. And so our Wildfire Project Management is a new group created in the last 18 months. As you can see, we were obviously doing a lot of wildfire work, installing a lot of covered conductor and new sectionalizing devices. So that drove the need for a new department dedicated solely to those projects in high fire areas. Our DPM is responsible for basically all the projects not in a high fire risk area. So that's the separation of those two groups there. But we work closely with our project managers. Before this call, I just got off a call with one of our wildfire project managers on some conductor we're installing. Next, we have our distribution apparatus group. They're responsible for field verifying and endpoint testing our apparatus out in the field. So a remote automatic recloser, a remote control switch. Someone has to make sure that those devices are working properly and they have the right settings. So we work closely with them to make sure that they have the right settings for the right device. And if there is, let's say, an error with the device, it's not acting as we anticipate it to act. We have, for example, a remote control switch, and the switching center is sending the close signal and the switch isn't closing. They'll have to create a trouble ticket, and that'll come through us, and then it'll get routed to distribution apparatus to verify that, is this device still needed? Does it still have the right settings? And then they'll go in and fix the device. Down here, we have our troublemen. Every district has a number of troublemen that are on duty 24/7, and they have a wealth of knowledge. They're out there driving around every single day. They're very familiar with the area. They know all the poles and any situations that might arise. So it's great to talk to them. We have monthly district meetings where we basically just sit down and we're like, hey, how can we help you guys? What are some issues that you're currently facing, and what can we do to support you? Next, we have a new group, which is operations engineering. They actually sit inside the switching centers. So this is also a newer group. All of our operation engineers used to be distribution engineers. That's currently the only way to become an operating engineer is to go through distribution engineering. And so they sit in the switching center, and they typically do a lot of real-time, reacting and engineering if necessary. So if there's a wire down and they're like, oh, we need to move this circuit over to pick up another piece of the circuit, they'll do a real-time review to see if that circuit is capable of handling the addition of that load. Next, we have substation engineering. We work with them anytime we need to sponsor a project, a new circuit, a new substation. Substation engineering is responsible for everything what we call inside the fence of the substation. That's their area of responsibility. And then everything outside the fence is where distribution engineering takes over. So the actual substation itself, they're responsible for that. And then, once it comes to that first pole outside the fence, that's where we take over. Next is our asset strategy and planning group. They are responsible for planning ahead. Like, do we need a new circuit? Do we need a new substation? That group will identify those needs. They also are very involved with the risk modeling that we do. So which areas need covered conductor and high fire risk areas? Surely not all areas have the same risk, and they do not. So where do we need to target the projects? So then they'll figure out the areas that we need to target, and they'll give that information to us, and then we'll start drawing off the project to move it down the chain. Next, we have our distribution automation group. They're largely responsible for a lot of the tools we use on the computer to see that our devices are working properly. Our RARs are showing the right amount of currents and the right voltages. So they also work very closely with distribution apparatus in maintaining a lot of our equipment. Lastly, we have protection engineering. They finalize the settings for the RAR. So we'll propose the settings based on the circuit loading for the area, and if there's a circuit tie downstream, we'll plan ahead for things like that if we need to roll some load. That way they don't have to change the settings every time. And then protection engineering goes in with a fine-tooth comb, and they go through our settings and they verify what actually needs to be installed, and then they'll approve it and send it over to distribution apparatus. So that's just a few groups that we work with. There are a lot of them, but it makes for a lot of interesting work. It always keeps me on our toes. So lastly, I'll get into a few of the teams that we have here. So this was the last picture that distribution engineering as a department took in person. This was our Christmas party, December of 2019. And if you look really closely, you can see me right here. Yeah, wow, throwback. But so let's highlight some of our great teams. First, let's talk about our leadership forum. They seek to bring current and aspiring leaders together to develop a personal leadership vision, develop leadership skills, and just kind of overall engage in activities that foster SCE's values. And they seek to inspire a commitment and ownership of an inclusive and empowered workforce. Next, we have our recruiting team that I'm a part of. So all my full-time job is, being a distribution engineer, and then I volunteered to be on the recruiting team. So I'm fresh out of college, and I was in your shoes literally just over a year ago. So I know what it's like. And I wanted to be able to connect with our campuses and be able to develop a pipeline of diverse students. So that's what the distribution recruitment team seeks. They want to forge and maintain relationships with university to establish a pipeline of diverse and qualified students that are interested in SCE. We accomplish this by supporting and attending campus events much like this one, while networking with our undergraduate and graduate students. Next, we have our all-important safety team. At Edison, safety is our top priority always. When you're dealing with high voltage power lines, you can die, and people have. So everyone should be able to go to work, work safely, and be able to go home with their families. There's nothing more important. So our safety team promotes wellness. They promote an injury-free work environment, and they do this by diligently energizing and integrating safety at SCE. Next, we have our training team. And our DE training team puts on an intensive learning process for new engineers in the distribution field engineering organization. An offshoot of the training team leads our intern training program. And all of our training programs, they exist to ensure the success of all newcomers in distribution engineering. We actively recruit all engineering majors, mechanical, civil, aerospace, electrical. We actively recruit all engineering majors. So our training program does not assume that the participants have an electrical background, because a lot of them do not. My mentor is a mechanical engineer, and she's probably the smartest person I know. So you absolutely do not need to have an electrical background to work for SoCal Edison. And our training team, they cover the fundamentals of all of our day-to-day activities. Lastly, down here, we have our Women Empowerment Forum. And our Women Empowerment Forum seeks to create relationships with women in SCE to support the pursuit of personal and professional development through mentorship and shared experiences. Our Women Empowerment Group they support a lot of local SWE chapters. So look for that in the coming months as well. We're currently putting together with an event with CSUN SWE chapter as well. I think that's the end of my presentation. So we can move on to the Q&A portion. If you guys want to ask your questions in the chat, I'm happy to answer anything that comes up.
I see some thank yous in the chat.
Yes, of course. Thank you guys for having me. I really appreciate the time.
They may have already asked their questions, but we'll give this a minute or two to see if students have. Oh, here we have somebody that, oh, they're popping in. I'll let you monitor that.
Lionel Martinez says, I just graduated with my BSME. Congratulations, Lionel. And then we have Timothy asking, do you recruit computer science majors?
Yes, absolutely. Sorry, yeah, that's a little misleading. We absolutely recruit computer science majors. We have a lot of internal applicants, or excuse me, internal applications that are designed and operated in-house. So that's one avenue that computer science majors could take if they're interested in being very hands-on and coding, or if you want to work in distribution engineering, apparatus engineering, protection engineering. There is absolutely a need for computer scientists in every department. Next question for Lionel. Yeah. Oh, sorry, go ahead.
Oh, sorry. He says, should I apply as an intern? And he just graduated with his BSME.
Okay, got it. No, don't apply as an intern. Our internship program is for continuing students. And we only have a summer internship program. Once you're a summer intern, you have the ability to be converted to a year-round intern. But you have to be a summer intern first. Our summer internship is for continuing students. So you have to be able to be enrolled in the fall of that year. So I would apply for our entry-level positions. You can absolutely, let me put this in the chat, go to edisoncareers.com and look at what positions are currently posted. There are a few positions with engineering in the name, but if you also look at the planning group, our planning groups have a lot of engineers as well. Asset strategy planning is almost exclusively engineers. So just because it doesn't have engineer in the name doesn't mean you're not doing engineering if that's what you're interested in. So absolutely apply to our full-time positions.
And Michael, we have Christian asking, can you give us a little more insight on how the training process with SoCal Edison?
Yeah, absolutely. So it depends on how you come in, but they're mostly the same. First, you'll come in and you'll get a laptop issued to you. And then from there, you'll get a bunch of very generic training material that is like HR based. So like a sexual harassment training, how to behave in the workplace. And then from there, every single intern and new hire gets assigned a mentor. And their mentor is largely there to help support them in their day-to-day. And that will help bring them up to speed on all the projects that they're currently working on. So there's probably like a week's worth of training, like right off the bat, that is just like computer-based training and isn't the most interesting. But once you work through that, that'll get you all of your authorizations and accesses. And once you have all those accesses, then we can actually get you the tools that you need to look at, what's going on the grid. And specifically our training programs, those start 2 to 3 weeks after you're first hired, and that's put on within our department specifically. And each department has their own version of this, where they will train new hires into what their department does in their day-to-day activities. There's also like a company-wide training program that's just like one session. It's all day, and it tells you like, how does a utility make money? Who do we serve? Why do we do what we do? How do we do it? So it gives you a lot of background into many different facets of the business. And every new hire has to go through that program or that training. That's only one day though.
And then we have Sandeep asks, are there any opportunities for students in business management and finance?
Absolutely. We have an MBA program that exclusively recruits current MBA people that are getting their MBA. Additionally, we have lots of non-technical areas. So power procurement, project management, I'm missing so many. Just because I don't directly interact with them every day, but there are absolutely tons of opportunities for business people and finance people. I know our audit group, our accounting group, they all recruit business and finance majors. Our power procurement group, Absolutely. There are absolutely opportunities available to you. I remember last year we had 150 summer interns, and 110 of them were engineers or computer scientists. So 40 of them were not. And I think the large majority of those that were not engineers were business majors.
Yeah, Mike,
And
I just want to add something. Michael, I did see in Handshake that there were some summer internships that were for business majors. Yes.
Absolutely.
Go ahead, Kristen.
And related to that, I would say Alex asks, would a marketing degree be good for Edison?
Absolutely. I just worked with our marketing department for the first time. This was for Tau Beta Pi at CSUN, getting one of our presentations a little broader influence. They posted it on the official SCE LinkedIn. So that was crazy. We absolutely have a marketing department. We actually have a couple, depending. There's like local marketing, and then there's a more broad marketing. It depends on what specifically you're interested in, but absolutely, we need people of all backgrounds.
And Michael, Christian asks, are there any spots left for the summer internship? I checked online and the internships are posted in fall.
That's correct. So there aren't any spots left for this summer. All of this summer's interns are either already hired or they're in the closing stages of extending offers to folks. So we primarily recruit in the fall, and then we take the spring term to hire all those folks and then bring them on board for the summer. So there are currently no openings, I think, for engineering internships. The business internships might have a couple spots open still for this upcoming summer of 2022. But in general, the answer is no, most of them are closed.
I just want to add something there, Michael. Most large companies will recruit in the fall for summer. And I know that's something that students, it's a kind of a learning curve for students because they think it would be spring, but the process takes a long time. So a larger company, there are a lot of summer internships available, but you'll find certain companies, larger companies typically recruit in the fall.
Yeah, I was recruited in the fall of my freshman year for my summer internship. And you can imagine I didn't know much about anything the fall of my freshman year. So that's important to note about like what skills are we looking for. First and foremost is it's excellent to be able to demonstrate any sort of leadership experience, whether it's in a club, maybe at a sales job or being a server, something like that. And then we really only look for like the basics. So I remember the only technical question in my interviews was, can you explain V equals IR, which is voltage equals amps times resistance. And so that's introductory physics. So the very, very basic technical questions that are asked, because we recognize, you guys are not professionals, you're students. So yes, absolutely apply in the fall.
And Michael, the last question in the chat here asks, what software or program do you work with the most?
That's a good question. What software or program do I work with the most? Outlook. I do so many emails every day. That's probably not exactly what you're looking for. A little more technical. We have a program called SIME, which is similar to Spice, where we model our circuits in. And so I do a lot of circuit modeling in there. I also do a lot with Excel and PDFs, so like Adobe, where I'm like drawing on maps to scope out all the projects. So there isn't one program that might be particularly useful, but being able to adapt to new programs and learn quickly is definitely in your best interest. Also, if you are able to use the references and tools available to you. So we have a lot of design standards, and a lot of questions that people have early on can often be found in there. So if you know how to control F, that's huge. And so you have to be willing, obviously you have to know where to look if you have a question, but we have like 2 big manuals. And if you can just open it up and control F, that'll put you leagues and bounds ahead of a lot of other interns.
Okay, so I think we're just about out of time. We can take one last question if we have one. Up, we're getting some thank yous. Go ahead, Kristen.
Nancy asks, you said engineering internships are closed. What about IT?
That's a good question. I think our IT roles operate on the same timeline as our engineering ones. I know that there are currently a lot of so if you're like graduating this term, there are a lot of IT jobs available. If you go to the Edison careers link I posted, and filter for information technology, you'll see all of those job postings. But I think also our IT summer internships are closed now as well. I know I imagine they have maybe a little more specific technical parts of their interview as well, and those take time to schedule out ahead of time and get them with the right hiring managers.
And as Michael mentioned, you can go to the website, check on the website to see what's available, and apply. Well, I want to say thank you so much to Michael for his presentation today. I learned a lot. This is not my field of strength, but I think it was a good opportunity for you today to learn from an expert in his field. So
Thank you so much, Jen.
You're welcome. Goodbye now.